All right, so try to do this where you can see me and the work. I don't know how good I'm doing at this. So I'm gonna try another method another day. All right, so this first problem tells us Joseph earns $15 for every hour he moves. He mows, my fault. Is the money he earns proportional to the number of lawns he mows? All right. So he mows a lawn, he gets $15. All right. Now this first row is the number of lawns he mows. So if he mows 0 lawns, he earns $0. All right. Then if he mows 1 lawn, he earns $15. All right. If he mows a second lawn, the number of lawns increases by 1. That's how we get to 2 lawns. So he's mowed a total of 2 lawns. All right. He's gonna earn $15 more. Now he's earned $30 in total. All right. Now he's gonna earn, if we add another lawn, he earns $15 more, up to $45. All right. So a lot of y'all understand this. What we need to focus on is the language you use to write it in. All right, so we want to get back to that key vocabulary. Some of y'all didn't see yesterday because you didn't do all your homework, but I'm going to pull it up again today, and we're going to use it to write. So we're looking for phrases like proportional, relationship, corresponding, all right? But in this case, yes, it's proportional. Because both quantities increase at a constant rate. All right. Go on to the next one, right? It says at the end of the summer, Caitlin had saved $120 from her summer job. This was her initial deposit into a new bank account. All right, so first of all, Caitlin's saving money. We like Caitlin. She's thinking ahead. All right, she's working. We like Caitlin. She's taking care of business. All right, so she goes and deposits her money in the bank account. Bam. So how much money she's got in the bank? $120. We know this. All right. As she starts the school year, Caitlin is going to deposit another $5 a week from her allowance. So now she's not working, but the little bit of money she gets from her parents, she's going to take a part of that and save it. All right. So we're going to save another $5 a week. All right. Is her account balance proportional to the number of weeks that she saves? Now, key thing here is not how much money she's earned since the start of the school year being proportional, but is her whole account balance proportional? All right. Now, in number 1, I started with 0 because if a relationship is proportional, when it leaves the origin or when both factors are starting out 0, it'll increase at a constant rate from there. Okay. So when she's at 0 weeks of saving during the school year, she's already at $120. All right? That's what her bank account is, not her new savings goal. It is asking about her whole account balance. All right? So 1 week goes by. Bam. Let's chart it. She's grown by 1 week. We've also saved $5. All right? So her new balance is $125. Now that's good. All right? And she's being responsible. So another week goes by. Look at that, I messed up. We want to add 1 week, but we're at a total of 2 weeks. Well, her account balance is going to increase by 5 more to get to $130. A third week goes by. We add another week. We're at 3 weeks. She adds $5 more to her bank account. She's at $135. If we look at this rate, right, our rate of change seems to be pretty consistent. The problem is that when we're at zero, if zero is here, we move up $120. So in this case, it is not proportional to the number of weeks because it does not increase at a constant rate. Because how did I get from 1 week to having $125 to 2 weeks to having 130, 3 weeks to having 135, and at 0 weeks of saving, I'm already at 120. All right, so that pattern doesn't match. Yes, it grows at a constant rate of $5, but I can't move from the origin at an even pace. All right. No, it is not proportional because there is no constant that can be multiplied at any time to get the corresponding balance. All right. All right, so it takes a little time to write it. All right, let's look at this last one. All right, we got Lucas and Brianna. All right, they read 3 books each last month. They're killing it. They're literate. You know, they're exploring the world through the lens of other people's eyes. We love it. The table shows the number of, and it should say the table show the number of pages in each book and the length of time it took to read the entire book. All right. And it looks like we're comparing time and number of pages in a book in hours. All right. So for our first friend, our first friend read one book, 208 pages, 8 hours. Read another book, 156 pages, 6 hours. Read another book, 235 pages, 9 hours. All right. Then our second friend over here also read some books at a variety of times. Our question for A is, which of the tables, if any, represents a proportional relationship? All right, so first we need to determine if there is a proportional relationship by taking a unit rate, right? So that's the first thing we want to do. And we want to know pages per hour. All right, because we want to see about how long it's taking them to read a book. So to solve this correctly, I would determine a unit rate for each of the readers, Lucas and Brianna, and then I would find out if the unit rate could be applied across the board. Because for these to be proportional, they all need to be equivalent ratios, which means when I reduce them to their simplest form, I'll have the same fraction. Again, it'll be increasing at a constant rate. Up here, it was 1 in 15. Down here, we did not have a unit rate that could be applied across the board. And here, we're determining if they do. All right. Now, I can look at this and do some math. Let me grab one of these calculators. All right. First, 208 pages divided by 8 hours gives me a rate of 26 for every 1 hour of reading. All right. All right. So I know if 1 hour goes by, Lucas read 1 page. Let's see. 156 divided by 6. Also 26. 234 divided by 9. also 26. So Lucas definitely has a proportional relationship. Lucas's chart is proportional. Now let's look at Brianna. 168 divided by 6. Bam, we got a rate of 28 pages in 1 hour. So far, she's reading faster than Lucas. Now I can visually look at the next one, 120 divided by 4. I know that 12 divided by 4 is 3. 4 times 3 is 12. 12 divided by 4 is 3. I know that 120 divided by 4 then is 30. So I already know that these are not proportional because in the second book, she's read 30 pages per hour, okay? So we're going to say Lucas's chart is proportional. Brianna's is not. All right? And we have to explain this. Just the correct answer is great, but what's your evidence? Why do we know what you say is true? Right? I know over here that it's true because Lucas's chart indicates he reads 26 pages per hour. Brianna's chart changes in each column. Bam. Killing it. All right. Then the next one, it asks us, both Lucas and Brianna had specific reading goals they needed to accomplish. What different strategies did each person employ in reading each of those goals? Wow. Okay. Now, this is actually an interesting question. So I expect some variance, some change, some difference in your answers. This wants a mathematical answer. It wants you to presume that when a person has a goal, the most logical step is to think mathematically, and I believe that's presumptuous. So your exact answer would be, Lucas chose to read at a constant rate. He probably set himself on a schedule, put himself on a timer, and you can see that there's probably a pattern in a schedule there because it happens the same way every time, all right? Whereas our friend Brianna probably just took the time to read when she was ready to, read in large chunks, small chunks, and just worked towards her commitment because there's no real pattern to how she did her work, all right? The reason that matters is because as human beings, right, when we plan something out and we structure it on a pattern, we can see it. And for some of us, that routine helps us meet goals, all right? But that doesn't have to be true for you. Maybe you just set a goal and you meet it with a fluctuating pace, all right? Think on that. But yeah, do your homework.